Okay, it's nearly 5 minutes past, so let's kick things off, guys. Hello, everyone. It's Alan Mourgues here. I'm the founder of CrowdField, which is a hub for oil and gas pros to come together, collaborate, and develop cool stuff. And today we're going to be running this session, which is about unlocking insights from unstructured reports. So we're going to learn how to leverage AI and large language models to turn unstructured data into structured data. My guest today is my partner, Yohanes Nuwara. He's the founder of GeoDataX, a startup focused on unlocking insights precisely from unstructured oil and gas reports. He's an expert in data science, computer vision, and large language models. He's worked across Norway and Indonesia, and he's advised companies not only in oil and gas, but also in pulp and paper and others as well. He's also a passionate educator, and he's a prolific Python coder. And as a matter of fact, he's going to be running a couple of Python courses over the next few weeks. Before handing over to Johannes, just the usual housekeeping. We're going to have about 40 to 45 minutes for the talk and some 10 to 15 minutes for Q&A at the end. Please stay muted throughout the session and just raise your hand with a little hand icon at the bottom of the screen if you want to ask anything, and just wait for my cue before unmuting yourselves. Otherwise, just simply type the question in the chat box. This session is being recorded for later distribution. And with all of that out of the way, I'm just going to hand over to Johannes now. Let me just allow screen sharing. There you go, Johannes.
Okay, thank you, Alan,
Feel
for the
free to share
introduction.
your screen, mate, and take it away.
Yeah, sure. Okay. I will share my screen now. Do you see my screen already?
We see your screen. Just put it in presentation mode and we're good.
Yeah.
Great.
Clear?
Yeah, all
Okay.
clear.
Yeah, okay. Thank you. Thank you, Alan, for organizing this webinar for, I think, for the third time or fourth times, right? It's really great to see you all here. I saw some participants joining this webinar. As Alan already introduced, my name is Yohanes. You can call me Yohanes. Right now, I'm working as a data scientist for a company in Norway. So today, I want to present something which is interesting, very interesting with the current trends in AI. If you have heard about GPT-5, that is just dropped yesterday, and also the GPT-OS 2 days before. So that's very interesting, and that's a very dynamic field. And in oil and gas, as a professionals, we need to stay up to date with this kind of trend. So my talk today is to give you or sharing with you knowledge about the LLMs or the AI, which is currently growing, and also about how this LLM can be applied in oil and gas industry as a standards. All right. So a bit intro. Actually, I founded this GeoDataX just as personal project, a very small project. But then I met with Alan. He is a very prolific and very expert in reservoir engineering and oil and gas. So I partnered with him, and it grows as a bigger project right now. And we currently scout for different technologies to serve oil and gas companies in this kind of field of AI. So today I want to share about 5 points here. First, I want to share some knowledge about LLM. What is LLM? Maybe you have heard about ChatGPT. You use ChatGPT many times in your daily life, right? But what is exactly LLM? And then I want to deep dive into the use of LLM in oil and gas, specifically how it can be used for RAG, retrieval augmented generation, and also for data extraction, because these two are very crucial in today's business. So Just yesterday, I just come up with this cute or this representative diagram to cover exactly what is going on with the unstructured data. Let me just introduce what is unstructured data. So if you are working with reports, with text, with documents, with images, those are called unstructured data. But most of us, as a professionals in oil and gas, we use numbers all the time. When working with reservoir engineering, we use software, we use numbers, we use Excel. So we rarely touch this data as a reference, just as a reference, not as a main data, right? So the problem is that this data is actually 80% of our industry. So we annually we archive lots of unstructured data, whether this is images or whether documents in the archive. Only 1% of the unstructured data is used for analysis or for simulations. So this is a problem when we deal with unstructured data. And there is currently no available or appropriate solution on how to handle this data appropriately, right? So we just deal with the reports. We read these reports. So that's how we work in the oil and gas. But right now, we know that there are lots of updates in AI. So large language model, if you are talking about large language model, I want to ask which kind of large language model are you working with? So of course there are ChatGPT, there are Gemini, there are Cloud, Sonnet, you can name it, right? But there are two basic categories of LLMs. The first one is ordinary LLM, which is actually this model only receive text. The second one is called multimodal or visual language model, which can receive not only text, but also videos, sound, audio, and also images. So if you see here, these are just a basic landscape of our today LLM. There are also other categories of LLM, which is called open source, right? So open source is just you can use it for private use. So this open source LLM is very important in industry because we don't want to share our confidential data. So there are lots of potentials in this open source. So it's not using API to serve this LLM. And then if you are talking about LLM, there are lots of sizes of the LLM. So from this representation, we can see actually that every language model, they have different sizes. Like for example, Llama. This is from Meta, from Facebook. It has 90 billion parameters. You don't need to worry about what the parameter means. It is basically the parameter on behind how the large language model is designed. So different large language model, they have different sizes. And we see here the smallest one is called small VLM, which is Hugging Face. So if you see from the top, Llama is from Meta. The second one is from Alibaba. The third one is from IBM. The fourth one is from Google, DeepMind, which you may be familiar with Gemini, for example. It's from Google. And the last one is from Hugging Face. So we have this kind of parameters in different large language models. And then these two often appear in our decision whether we need to go for API-based or we need to go for on-premise. Of course, for on-premise, it serves privacy, it serves security, right? Because you only use LLM in your server. So this kind of decision often comes into your mind whenever you want to use AI in your projects. But I really advocate for the use of on-premise because on-premise is more secure. There is a technology called Olama. To host this Olama, you can use to interact with the LLMs very securely. So you can just download this Olama in your laptop, and then you can do the Q&A there. So you don't need to expose data to the ChatGPT or any other providers. Okay. So in 2024, which is last year, you may have heard about ChatGPT for geology, which is called Geology Oracle. So you can browse this Geology Oracle. This is developed by University in Italy. So if you have questions about geology, this Geology Oracle is quite accurate in giving the answers for geology. So this is quite interesting when we are dealing with the LLM or AI in general, because AI is not a it's not a baby actually. It's a very big stuff. Like because the inner working of AI is very complicated, and we cannot use AI in our consumer devices because it is a very big algorithm that runs with a few computational algorithms, right? So so we can see here. You have heard about GPU. GPU is what we call as a graphic processor unit. So it originally used for images for displaying graphics in your computer. But this GPU is also used to accelerate processes in the LLMs. So if you have CPU, that's fine. But if you have GPU, it can accelerate your LLM faster. If you see here, for example, we have a lot of options in the NVIDIA. So it's, for example, like P4 or Ampere or Volta, for example. They have different speed, and also they have different RAM. So when we choose what we want to use our LLM or train our LLM, we need to choose also what kind of GPU is appropriate for our LLM. So these are just the landscape of how reports in oil and gas are varied from one report to another report. So you can see here, these are very typical reports. I used to work with STAR report, with RCA report, petrophysical report. Also, not a long time ago, I used to work with PVT report. For this year's, I used to work with PVT reports to do a lot of things using this PVT report. So there are lots of different reports, right? Geophysical reports like seismic report, for example, VSP or CPI computed log. There are lots of different reports, and they have different templates. They have different styles, right? So in oil and gas, this kind of reports are very interesting because um, it is not a single template. Also, if we are dealing with laboratories, they also have different standards of reports. Like what what I recently worked with PVT. I recently worked with Core Lab, for example, or Stratum, or Weatherford reports, for example. They have different kinds of templates or layouts. So this is what I call as multimodality. So it's a very different styles and templates that we use in Olympus. So if we are talking about back to our discussion about unstructured data, so the problem is that this kind of data is rarely used. But once we get involved to this unstructured data, it takes lots of time to read this report. One report can take like 200 pages, 300 pages, right? And then we need to read for all of these pages. So these are the real problem that the industry is dealing with, but this is not a very crucial because they are handling with the software, but these are also one of the daily jobs in as engineers in the company, right? So of course, when our colleague leaves, for example, or when we leave the company, for example, we created a few reports, and then this report is never touched because when someone leaves and this report stays there in the company, it never passed to the next colleague. So this kind of knowledge base is rarely touched in this industry. So if we are talking about how we can use our technology, our AI to solve this problem, there is a terminology or technology which is called the RAC, or retrieval augmented generation. So this RAC appears to be very effective in helping to process these documents. Um, if you have like 1,000 of documents, you can use this work to quickly sort through this document. You can ask your questions, very specific questions, and then you will get the answer from these documents. So this is how RAC works behind. So you can simply just type your question in the system, and then it will search the documents using the LLM or the AI, and then you will get back the answer. So it's just like that. It's a very simple process. But behind this retrieval system, there is a very complicated process. So I want to show you this animation that we create in GeoDataX. So I will play this video, and then I will explain to you later.
We have a question and we want to know which document is relevant. First, each document will be divided into several patches, or small images. Every patch is represented by a number. Here we have 16 patches, so we have 16 numbers. This process continues to the second document. These numbers, altogether, make up a vector which is called document embedding. The question, how does the fracture orientation behave, is also converted into vector called query embedding. The similarity score is calculated by comparing the query and document embedding. If similar, it is marked blue. Otherwise, marked orange. The ratio is called similarity score. Here we have 43% similarity. This process then continues for the second document. The same query embedding is evaluated on the second document embedding. In this document, we have more similarity than the previous document. As the calculation continues, we get similarity score of 81%. Thus, the second document is more relevant to answer the question.
So these are the process behind RAC. So it starts with, if I just play along once again,
We have a question.
and then I pause for some moments here. So we have a document, and then the next process, it will patch this document into several patches or small images.
And we want to know which document is relevant.
So the problem is that if we compare these two documents, and we are going to ask which document is relevant to our question. So, and then this will...
First, each document will be divided into several patches, or small images. Every patch...
So this will create patches, and every patch, it will create also embedding. What is an embedding? Actually, embedding is this, it's in mathematics, embedding is a vector. But I'm going to simplify this as a number. So every patch, they have one number, which is assigned to number. For example, the first patch, it is assigned to 0.1, for example, and the next one, it is assigned to the 0.8, for example. So it goes from one patch to another patch and then assigned to a number. And this process is also applied to the next document. So if we are, if we see the animation,
patch is represented by a number. Here we have 16 patches, so we have 16 numbers. This process continues to the second document. These numbers, altogether, make up a vector which is called document embedding. The question, how does the fracture orientation...
So from this two document, we will have two embeddings, right? So we have two vectors. And from these two vectors, next, we will compare which vector is most similar to my question. Because the question that you ask in RAC will be also converted to an embedding. So this is how it goes.
Can behave. is also
so you have this question above, and then it is also converted to this embedding, right? And then what it does is that it compares one by one number. So as I said, actually this is a very simple animation. So behind actually this is more complicated, but this is just how it appears in this rock. So we have this kind of comparison.
converted into vector called query embedding.
And
We have a
then
question and we want to know similarity score is calculated by comparing the query and document embedding. If similar, it is marked blue. Otherwise, marked orange. The ratio.
So it will go from one number to another number, and it will be continuously processed to the next document. So that's how RAC works. So this RAC is very effective in finding what is the most similar report, which is relevant to our question. So behind this model is called the visual embedding model. This model is an AI model, or is a large language model that will process the document into embedding. And when we are talking about RAG or retrieval augmented generation, of course, we need to store lots of data, lots of numbers in our database. So this is called vector database, which is used to store this embedding, which is generated by the documents during the RAG process. So there are a couple providers in the vector database. So each provider, they have different specifications. So these are just the landscape of how available vector database currently is in the industry. So we have made a RAG in our product as well. So when we do something with RAG, we need to evaluate the accuracy on different topics. So here we have accuracy for reservoir engineering, for example, and then for general questions, for drilling. And also we evaluate the accuracy on different use cases. Maybe it's just a question and answer, or this is for the graph understanding or the table understanding, or summarizing, or the image description. So we need to evaluate our system continuously. I'm going to show the second video. This is what we are currently developed in our product. So I'm going to show how RAG can reduce the searching time up to 80%. I'm going to skip to minute so that we can just see what is important. So maybe here. Okay, I'm going to start from here. So here you just ask your question, and then you will have the answer using the process that that I explained earlier. So the beauty of this RAG is that it can understand a very specific question, whether this is a PVT question, or this is a drilling question, or this is a petrophysical question. It can understand clearly what you ask, and then it will directly give you two relevant documents or pages, which can answer your question. And then not only the document, but you also have this answer by the RAG service here. So not only we evaluate the accuracy of what document is coming to you, but also we evaluate the accuracy of that answer. So the LLM needs to answer inside this document. So there are two stages in this RAG. The first one is retrieving which document is most similar, and then the second one, it answers the specific question in the document. So this is these are two stages in this RAG application. You can go to here to this YouTube to see more about GeoDataX, but I'm going to explain to you another application. So I'm going to introduce you to other application of the LLM for the data extraction, because I believe that most of us engineers are working with reports, and we used to extract very important data from our report into Excel, for example, because we used to work very often with Excel. So we actually we often use OCR, the optical character recognition, which we can see very widely available in the internet. You can just browse this OCR, maybe some free OCR tools. But the disadvantages of this OCR is when we deal with old reports, and then also it only depends on very specific templates. So it cannot be applied to different templates. Let's say we have this specific template, and then we cannot customize this OCR because it is a just rigid application using using image processing. Now, if we shift our paradigm to large language model, we can steer our LLM to be customized for our specific report. And the goodness of this LM is that it is very, very accurate in old reports because it is based on language, not based on visual cues. So, so it adjusts to the language in the report. So it gives us more accurate representation of the document or report. So here is just a pipeline of the LLM-based extraction. So we can go from reports, and then we can give it to the LLM, and then we can produce the JSON or the Excel file that we usually use. So this is how we design our data extraction. So first, if we see in this report, it has two important data. The first one, if we can call it as the metadata, it consists of sample number, and then permeability and also porosity. Here is an example of a petrophysical report, the MICP, and then we have this data on the right side here. So here we can divide these two information from the report. And then this is how we design our prompt, because LLM is we do lots of we do prompting in LLM. So this is how we can use the LLM to extract the data. We can specify our prompt. Here we can specify the role of the LLM, what to do. So we ask the LLM to extract the data, and then it needs to put into JSON file. And but before that, for example, this example is a petrophysical report, so it needs to classify which category is this page, for example. So if we use if we are seeing this base data, for example, electrical drainage, there are lots of categories. Also, for the first category, we give the instruction, and also we specify the JSON scheme. And I'm going to show the one of the demo for this data extraction, but it can be also applied to well schematic, for example, if you are working with a well schematic or well completion report. So it has this well schematic diagram and also the data there. So often we need to represent this data into Excel. So that's how we can use the LLM to extract this data. So this is the one of the example of our results. So we have the Excel and also the modern schematic. If you see there, most of the reports, they have black and white diagram. We can reconstruct this diagram into more modern look. So we use entirely AI in this process. I'm going to show the video. So this is just a quick demo of how we use LM to extract this data.
Petroleum engineers are working with well completion schematics most of the time. In this example, a well schematic is displayed in PDF report, where it has information about length, depth, and diameters of each components. In GeoDataX, we have made a tool that extracts information from well completion PDF report into Excel spreadsheets and build a modern DHD component diagrams. In this tool, we just need to upload a PDF report. Next, we wait for a few seconds to finish the extraction. We use AI to scan through the document, convert the table into JSON format, and finally produce an Excel spreadsheet. Once finished, we will have the Excel result, which is ready for download. Inside the generated Excel spreadsheet, we will have a table displaying all the components with information about the length, depth, and diameters of each component, the end of tailpipe information, and also a modern diagram. This diagram is generated automatically with AI, using the information that is displayed in the table beside.
So the input is simple. We can just upload our report, which is in PDF, and then it will spin out the result, which is in Excel. And if you look at the Excel, it will be similar to what is presented in the report. You have the table there. You also have the information about the about if I go here once again.
Components with information about the length.
So you have also the length, the specifications, the components, detailed components, and also the diameter of each component, which is related to what we see in the report. And also, what is cool is that we can also reconstruct this well schematic. So this well schematic is assembled one by one component, which refers to what we have here in this components. So this is the beauty of how we use the LM to extract data from reports. So if you have PDF reports and you want to automate these reports into database, for example, we can use the LM to automate all of these processes.
Depth.
So I'm going to close this presentation today. So what we have today is about the LM, right? So LM is a very cool technology. I bet that I believe that you use LM daily in your daily life and also your career, right? So I use ChatGPT for my preference. LLM is very transformative and disruptive in the industry. So it revolutionized how we work. And this LM can be also used for ROC, and this already proven to reduce the searching time and how we work with the documents, for example. And also it can be also used for extracting documents from the reports, the data from the report. So all of this are enabled by AI. So I hope that there will be still spaces to continue after this. So we are keep growing and growing as also the AIs keep growing. So we need to be updated with this new technology, so it can help us to work better in our career. So I think that's all from my presentation. Thank you very much. I really appreciate each one of you who joined this webinar. If you have any other questions, please just fire away. Thank you.
Thank you, Yohanes. That was a very interesting look at the behind the scenes, all the magic that happens in the back end. Definitely interesting for folks who are obviously only exposed to the front end and the very simple user interface these tools provide. So it's very cool to have a look at what happens behind the scenes. I thought that first slide was brilliant with the statistics from the ESP was crazy. 80% of data is unstructured data. That's insane. So that second box on the right there, I wasn't aware of that. So any tool that can streamline getting insights from unstructured data is definitely a game changer. So I think this is a no-brainer. It's going to keep growing. Thank you very much, everyone, for joining today. It's a late Friday here in Australia. Probably most of you are in the in a different time zone, but thank you for joining. Thank you very much, Yohanes. That was very, very interesting. And as I said at the beginning, this presentation has been recorded, so it will be distributed on the YouTube channels. So again, thank you very much, everyone, and have a good weekend.